Welcome back to another chapter of Origo Lab's scrapbook. Today we'll be looking at the Rotary Evaporator, which is commonly known as the Rotovap. This machine has several main components: a vacuum pump that is attached to a distillation apparatus consisting of a condenser, a solvent trap that collects the condensed solvent, and a motor unit that rotates the round bottom flask, and finally, the heated water bath that sits below the attached round bottom flask. Before introducing your solution to your round bottom flask and attaching it to the Rotovap, make sure the empty flask is pre-weighed. Once the process is complete, you can weigh it again with your crystals to see your crude product weight. To attach the round bottom flask to the motor unit, take off the cap of your flask and slide it onto the apparatus. Then take what is known as a keck clamp and place the smaller side on top of the motor unit with the larger side on top of your flask. If you need to remove your flask at any time, grab the handles of the clamp and gently pull away from the round bottom flask. This will prevent breakage. Before beginning the process of removing the solvent, an instructor or TA will fill the container inside the condenser with ice water for you. When the solvent evaporates and is sucked into the condenser, it will immediately cool down and fall into the solvent trap below. If the ice in the condenser is partially melted, you can ask to have it refilled. Next, we must attach the tube that connects the vacuum pump to the condenser and turn the top stopcock here. This stopcock has a single hole in it and will thus control the evaporation of the solvent. If it's pointed up, the system is open to the air, which brings the system to atmospheric pressure. If it's pointing down, the system is open to the vacuum, bringing the pressure down and reducing the boiling point of the solvent. If it's pointing towards or away from you, the system is closed. This closed position will be maintained throughout most of the evaporation process, as we'll see in a moment. The bottom stopcock that I'm pointing to here should not be touched, as you don't need it to control the system. Here's a back view of the Rotovap. The small machine with tons of wires is the actual vacuum pump itself and has an on-off button facing you that controls the power. The machine in front is the motor unit. Now that everything is ready, we can turn on the vacuum pump and the Rotovap itself. Here's what the vacuum sounds like when it's on. Then, flip the switch on the top so your round bottom flask spins, preventing the solvent from boiling over. Right now, the system is closed, but I will open it momentarily to allow the vacuum to do its work. You normally don't want to leave the stopcock turned downward for more than a few seconds, as this will suck solvent into the pump, which causes damage to internal parts. I don't see any changes here, so using this bar here, I'm going to lower it into the water just slightly. Here, I've lowered the flask to where the bottom touches the water bath. The temperature of the bath should be no more than 20-30 degrees Celsius unless you're removing higher boiling solvents. And as a note, you should open the system to vacuum before you put the flask down in the water bath to prevent bumping and sudden boiling. Here's what it looks like. When you're keeping watch of when to close the system, you can watch the condenser as well as your flask. If too much solvent is falling into the solvent trap too fast, you should close the system immediately, as I do here. Wait until the dripping slows to about 1 drop every 1 to 2 seconds, and then open the system to the vacuum again. It will take some practice, but a TA or instructor should be supervising you for the majority of your time using the Rotovap. Here's another close look at what the solvent looks like condensing along the ice. After most of the solvent is condensed, you'll see some changes in the round bottom flask. There is little or no liquid left, and in this particular case, you're left with some white crystals along the side. Depending on the compound, you may get an oil, liquid, foam, or colored solid instead. You'll also notice that there's no longer solvent dripping into the trap along the condenser. What you should do now is raise the flask out of the water bath to allow the material to cool. Now that the process is complete, turn off the vacuum pump, turn off the motor unit, and then take off the keck clamp as instructed. To get the flask off, you must turn the stopcock that controls the system upward to bring the system back to atmospheric pressure, which can be heard now. It's a very high-pitched inhale. Wait for a few seconds after all the pressure to release. This will make it easy to gently slide the round bottom flask off. Now that you have your solid product, you will typically use a stream of nitrogen gas or air to remove residual solvent and will then be able to record its crude weight. Thanks for watching, and I'll see you in the next video.